So yeah, so basically that's the examples. So let's look at it from a table. So let's try to explain it from a table to say what are the hazards that are on the road, what is affecting the likelihood and what's affecting the consequence, and what type of mitigation do you need to do if you need to cross the road. So the hazards when you want to cross the road, one of the hazards, or these are some of the examples of the hazards. So the hazards or hazard may be cars, maybe motorbikes, maybe bicycles, maybe trucks, or anything that is moving on that particular road. So all of these will possess different risks depending on certain factors such as how fast are they moving or how near are they to you, and also just them being the way they are. Like if a car itself will possess a different risk because of how it's made, like how big it is and everything. A motorbike will also possess a different risk by just being a motorbike and how it's made. Bicycles the same, as well as the trucks. So most of the things that will affect the likelihood of you being hit, or you being that vehicle, anything that is on the road hitting you, is one factor that contributes to that is the condition of the road. So if that vehicle is moving on a well-tarred road, it means that most likely to be overspeeding, or the speed will be higher as compared to vehicles which are moving like in a gravel road. Therefore, the condition of that road will affect the chances of you being hit by this particular hazard. Then the location itself. So location. So if you find that so it may be, let me say it in this way, the same particular hazard, or the same hazard may pose different risks depending on the location. So you'll find that the drivers in Lusaka may be driving a Mark X differently from the drivers, let's say, in Chipata. So the same Mark X may be driven differently in these different locations depending on local authorities as well as regulations that are in these particular locations. So same particular hazard or same hazard, but then it will have like different risk levels in in different locations. Then we are talking about the speed. So how fast is this hazard moving? So if the hazard is moving at a very high speed, this will increase the chances of it coming and hitting into you, or an accident occurring as you're crossing the road. Then there's distances as well. So I talked about the distance. So if that vehicle is nearer to you, or if it's close to where you are about to cross the road, and also if it's speeding to add on, it means that the risk or the likelihood will increase, and therefore increasing the overall risk. So at that particular point, you may just need to wait until that particular hazard passes. Then that's when you can cross the road, but because then by that time the risk would have been acceptable for you to actually cross the road. So what factors are affecting the consequence of an accident occurring, or the consequence if the accident occurs? So the type of hazard, like I said, so if a small vehicle hits you, the consequences will be different if a larger one hits you. So if a truck hits you, mostly the consequence will be more fatal as compared to a light vehicle. Or if a motorbike or bicycle hits you, you cannot compare the consequence to the truck. So these hazards will pose different consequences. Then the speed itself, so how fast the vehicle is moving, or how fast the motorbike is moving, or the bicycle is moving, will affect the consequence if the accident occurs. So if you determine that the risk of crossing the road is unacceptable at that particular point, so after you've determined the likelihood and consequence, then you find that, okay, I cannot cross the road. So one of the mitigations that you do is you need to wait. So you wait until the particular hazard passes, then you cross the road. Or if you see that, okay, the vehicle is somewhere very far from you, and it's maybe moving at slow to moderate speed, you may just need to increase the pace at which you are crossing the road. So that one also becomes a mitigation, so that by the time you are crossing the road, that vehicle, by the time that vehicle is reaching where you're crossing the road, you would have already crossed the road. So let's look at a comparison now. So we're talking about you crossing the road, and then we're trying to look at or relate it to the laboratory. So for you crossing the road, like we earlier determined, the hazards mostly are your cars, your motorbikes, your bicycles, your trucks, and the like. But then in the laboratory, what will mostly be your hazards are your biological agents, your toxins, and your chemicals. Of course, if we talk about your biological agents, so there are different types of biological agents. So just like the cars, there are different types of cars with different sizes and makes and everything. Same applies to the biological agents. There are different types of biological agents. So there are certain biological agents that are more lethal if you get exposed to them. Like the disease you get is more lethal as compared to other types of biological agents. So we may liken, let's say, the smaller vehicles. Let's say if there's a Corolla, we may liken the Corolla to certain biological agents such as your non-pathological E. coli's and your normal floras that you are handling in your lab. Those can be likened to like your smaller vehicles such as your Corollas and everything. But then we can liken now these let's say more lethal type of so for the first example I said, so the less lethal such as the cars, such as the Corollas, you can liken them to E. coli and other normal flora. But then for the more lethal type of biological agents that may cause serious disease if you get infected with them or if you get exposed to them, we can liken them to like a truck, a very big truck. So examples for the laboratory, we can have your cholera, you can have your Ebola, you can have your anthrax. That's if you are doing culture. So all these can be like your trucks in terms of hazard comparison. So of course, the consequences will be greater for the trucks, just like the consequence will be greater if you get infected with Ebola or anthrax or cholera. That's if it's in the culture or pure form. Right? So now let's look at the factors affecting likelihood of the accident or incident in this case, if we're talking about the laboratory. So for you crossing the road, we said condition of the road, the location of the particular agent or hazard, the speed of the hazard, and the distance at which the hazard is. That will affect the likelihood. So in the laboratory setup, what will mostly affect the likelihood of you getting exposed is the agent properties as well as the chemical properties. So is this particular agent more virulent? Is it what's the infectious dose? What is the host range? So if it has greater virulence, if it has more host ranges where it can infect both animals and humans, it means that the likelihood of you getting exposed to them is higher as compared to something which has properties which are lesser in degree. Then also, if you need to get exposed, or if you get exposed, you're also looking at the procedures and practices, so that how are you handling these particular agents. So if you are doing culture on these particular biological agents, it means that the chances of you getting exposed will also increase. But then if you're doing normal serological tests, such as the rapid testing for hepatitis B or any particular agent, then the likelihood becomes a bit lessened as compared to you doing cultures. So what factors are affecting consequence if the accident were to occur? That is when you are crossing the road. and also for the incident to occur if you are in the laboratory. So what will affect the consequence will be the hazard type itself. For the road to be the hazard type itself. So is it a vehicle, or is it a car? Is it a motorbike? Is it a bicycle? Is it a truck? So that will affect the consequence. So the bigger the vehicle is, the more consequence it may pose to you if an accident were to occur. But then for the laboratory setup, what will mostly affect the consequence of exposure is one of the things that will affect the consequences if there is treatment or not for that particular biological agent. So if you find that the particular biological agent that you're handling has no treatment, it means that the severity of the disease will be greater as to that particular biological agent, which has treatment if you get exposed or if you get infected with it. And therefore, the consequence values or the consequence degrees will vary between these two particular biological agents. Then the host status, so you yourself, how healthy are you at the time at which you are getting exposed to these biological agents? So the host status also affects the consequence of the exposure. So, but then we'll look at these a little more in detail when we do the actual risk assessments, that is for biosafety and biosecurity. So let's look at the mitigation. So while it's crossing the road, mostly the mitigations that you do is you wait until the hazard passes, or you just increase the pace as you are running or as you are crossing the road. So mostly those will be the mitigations. Or if a truck is coming, another thing that you may add is that you may need to just step back a bit. So if you need to cross the road and then you see that the truck is coming, you will not stand where you're standing. Mostly you'll be scared that maybe the truck may lose control. Therefore, you need to stand a bit back. So that is an extra mitigation so that you just don't get hit on that particular road. Now, if you go to the laboratory, some of the mitigations that you find there is that you just putting on the PPE will reduce the chances of you getting exposed to the biological agents, or you can eliminate the biological agents. So what how do you eliminate? The easiest way to eliminate, you just stop testing for that particular biological agent, then you would have eliminated. Or you can use engineering controls or devices that are engineered so that they do some form of primary or secondary containment. Then you have your administrative controls. So under administrative controls, this is where now your trainings occur. So you train people so that they are aware of what they are handling. Then you can have your SOPs or documents prepared so that people also are aware of what they're supposed to do at each particular point. So what you're doing there is that you are standardizing the procedures or activities in the lab. Then also you can just try to enforce a good laboratory work practice. So make sure that people actually do good laboratory work practice, such as disinfecting on a regular basis. Also, they can do some decontamination, and they can do some form of proper waste management. That way you would have at least reduced the chances of you coming into contact with whatever biological agents that are in the laboratory. So basically, this is the comparison you can make between you crossing the road and the laboratory. So the other slides that are following are just explaining a bit on the steps. That is the 5 steps to doing a risk assessment. So under hazard identification, so mostly here you're just determining your biological agents. So what agents are you using in the lab? But then after you look at the agents, you need to also consider what type of activities are you doing with these particular agents, okay? Because the different activities will pose different risks. So if you're centrifuging a sample, such as maybe for hepatitis B, the risk will be different as when you are pipetting that sample for hepatitis, or if when you are actually discarding that sample, that is when you are doing your waste management, the risk will be different at each particular point. So you need to consider, or you need to analyze what risk is posed at each particular point of the activity that you are doing with this particular agent. Then also you need to assess the agent properties. So what are these agent properties? You need to look at the pathogenicity, you need to look at the transmissibility, and also you need to look at the different routes of exposure. So all these will tell you something about where your likelihood and your consequences will fall once you start doing your risk evaluation. So under risk evaluation, this is where now you are doing or you are assessing what is the likelihood of exposure, and also what's the consequence if and when the exposure occurs. So you can either use qualitative or quantitative scales. So we're going to look at these different types. So there are certain matrices that use quantitative type of determination levels for likelihood and consequence. Others will use quantitative, others will use qualitative. Then if you find that your risks are unacceptable, you need to now prepare your risk control strategies. So these are the possible risk control measures that you may select or you may plan, so that you choose which risk control will be appropriate to either reduce or eliminate your risk. So you have your elimination, you have your substitution, you have your engineering controls, administrative controls, as well as your PPE. So this is a form of hierarchy, with elimination being the most effective and PPE being the least effective. So we're going to explain this in detail further on as we go in the sessions, not in this session, but then we'll do another session where we are just going to look at selecting and implementing risk control measures. Then after you've implemented or you've selected and implemented your risk control measures, you need to review the effectiveness of the mitigation measures. So you need to review on a regular basis. So as a laboratory, you need to define how often are you going to be reviewing these mitigation measures. So are you going to review it depending on the risk level, or are you going to be reviewing depending on the periodicity or period that you would have defined in your risk management SOP? So the best way, of course, to check effectiveness is you monitoring your incidences. I think I've explained already how you monitor the incidences and what they will tell you about the effectiveness of your mitigation measures. So yeah, so those are the steps. So if you need more information on risk assessment, and if you need to read further and you need more guidance on what requirements may be needed for risk assessment, these are just the various resource documents that you can get some of the information. So you can get more information from the WHO Laboratory Biosafety Manual. So the 4th edition has the latest information, so make sure you have the 4th edition. Then there's a monograph just on risk assessment, which supports the 4th edition for the Laboratory Biosafety Manual. So this one will just concentrate on risk assessment. So this is one of the best resource documents if you need to further understand risk assessment. Then if you need to know what requirements you need, or what requirements or standardization you need, you can read the CEN workshop agreements or the ISOs. So under the CEN workshop agreements, you have the CWA 15793 as well as the 16393. Then for the ISO, you have the 35001 and the ISO 15190. Then if you need more information that maybe the risk assessment monograph won't offer you, especially in relation to biosecurity, you can look at the WHO Laboratory Biosecurity Guidance, which will give you more information on laboratory biosecurity risk assessment. So basically, this is where you may want to get more information. So like I earlier mentioned, risk assessment is more of a technical type of process, and also you need to be analytical. So most of the time you need to do a lot of studying and a lot of background checks and a lot of research, so that you just get the correct information and you understand it from more. You can have more of an in-depth understanding of the process itself. So mostly if people just explain to you, maybe through the different sessions, there may be some information that may be missed. So it's always best to pick up a document such as the risk assessment monograph. You go through it and then you read and understand in detail on how to go about the risk assessment process. So since this is not really a live type of session, you can leave a comment either in the comment section, or you can contact me and then we can try to see where we can clarify one or two items. But basically that's the part one of risk assessment. So in part two, we'll look at we're going to jump into the biorisk management strategy, and then after that we'll look at biosafety risk assessment. That's in part two. Then in part three, we're going to look at biosecurity risk assessment. Then part 4 and 5, we are going to look at the biosafety risk assessment 2 and the biosecurity risk assessment 2 respectively. So thank you so much for following through this video. Hope it's been helpful. So like I said, this is just an introduction to risk assessment. So we are going to do other sessions that will dive into the actual information on risk assessment. So for now, this is all for part one. See you in part two.